My name is Rahul Baranwal, and today we will cover the topic bandwidth reservation in the quality of service. So actually, I am assuming here this is the topology. R2 is edge router and R3 is the ISP router, and there are two applications in our organization that is the critical one. And we don't want that any traffic should be dropped right if there is any congestion on the link or not. So we will just reserve 20% in 4 Mbps. That is the total bandwidth that we are getting from the ISP side. And for database traffic, we will reserve 25%, right? So how will we do that? So yeah, let's see. Suppose R2 is our is router would like to reserve bandwidth for two critical application based on the following. Yeah, would like to reserve bandwidth for two critical application based on the following. First one is web traffic. As we know that for web we use two protocol. First one is HTTP and second one is the HTTPS that uses TCP port number 80 and 443, and we will reserve 20%. And second one is database traffic. I'm just assuming it uses TCP port number 1521, right? And we will reserve 25% of 4 Mbps. How will we accomplish that? First, we'll have to classify the traffic. So to do that, first we'll have to create a access list that will be the extended one 101, so that we can specify here protocol and the port number both, right? So permit protocol will be TCP and source will be any, destination will be any, and our port number will be 80. Similarly, we'll have to do for HTTPS access list 101, permit TCP, source will be any, destination will be any, and port number will be 443, right? Now we'll have to do the same thing for database traffic access list and 102, that will be the second one, extended access list, permit, protocol will be TCP, source will be any, destination will be any, and our port number will be 1521, correct? Now here we'll have to uh, configure the class map. We'll have to give the name. You can give any name. I'm just giving the name as per the application. We'll have to match our access list via access group keyword, that is 101, and we'll have to create a class map for our database traffic. I'm just giving name as per application database. We'll have to match our access list via access group keyword, that is 102. Yeah, after classified the traffic, we'll have to specify the action. We'll have to create a policy map. I'm just giving the name pm-cos. Yeah, we'll have to call our class map in that is cm-wave, and we'll have to reserve the bandwidth, that is 20% as per our scenario, right? Now we'll have to call our class map for database traffic, that is cm-db bandwidth, and percent is 25, right? Now we'll have to call this policy map inside the interface in the outbound, right? So in this diagram we can say that our outbound interface is G2 by 0. Command will be service policy, and the shaping will always be applied in the outbound directions. So here output keyword and our policy map, that is our pm-cos, right? One more thing, actually in the outbound direction, as we covered in the shaping, that our average bandwidth is 4 Mbps that we are getting from the ISP side. If we don't put the bandwidth command in outbound interface, then it will take 20% of the link bandwidth, that is our 1 Gbps. So it might cause the congestion. So it's better to define the bandwidth keyword, bandwidth, and the bandwidth is 4 Mbps, right? So here it will be put in the kbps terms. As we know, in 1 Mbps there is 1000 kbps, so here 4000, right? So yeah, we'll have to go on the GNS3. We will start the router. We'll take the console of R2 and R3. Here we are using the subnet 192.1.23.0/24 between R2 and R3. So interface G2 by 0, IP address 192.1.23.255.255.255.0, no shutdown, and R3 interface G2 by 0, IP address 192.1.23.3, 255.255.255.0, no shutdown. Yeah, peer IP should be pingable. Now it's pingable. Now we'll have to apply all the configuration that we have written here in R2, that is our edge router. Let me zoom out. Yeah, we can verify the output. So policy map interface G2 by 0. So here we can see that it has automatically taken 20% of the 4 Mbps is 800 kbps and 25% of 4 Mbps is 1000 kbps, right? So one more thing here, we'll have to keep in mind that by default queuing mechanism is first in first out. That means whatever the traffic will come first here will go out first. So here we have reserved the bandwidth for our critical applications, but suppose there is congestion on this link, then our traffic will stuck here in our buffer memory. So to prioritize our traffic, we'll have to use the feature that is the LLQ1, right? So that will be covered in the next lectures. So I hope guys this lecture is beneficial for you. Yeah, thanks for watching. Bye.